Hello students, after some days again welcome to another episode of SB Math class. We are discussing about the functions and today hopefully it is the last class of the functions. Some short concepts are left. Today we will complete those concepts and then we will go to the next chapter. So the first concept, that is the algebra of functions. The algebra of functions. Very easy. Algebra means that is the operation of the real functions actually. So what are the operations? I am just writing in short. It is very easy. We will not waste the time for this one. So the first one is sum of the functions, that is f plus gx equals to fx plus gx. This is the sum of the functions. Now number 2, product. Product of the functions, that is actually here this is f plus g. This function is defined from a set x to the real number set. Like that only. Here also the function fg is defined from a set x to a real number set. So from here fgx equals to fx into gx. Those are very easy. Number 3, product. Product we have done. Multiplication by a number. Multiplication by a number, that means the function will be this one, cf from x to r. So it will be defined as cf of x is equals to cf of x is equals to cf of x for all x belongs to x. So those are the basic algebra of the functions, that is the operation on the real functions. Here sum means it will also satisfy the subtraction also. Here product means it will also satisfy the division also or quotient. For quotient it will be f by gx, and here also fx by gx will be there, and here f minus gx, so fx minus gx will be there. Very easy, and some short sums, 1 or 2 marks question can come from this concept. When a function is called the even function or odd function, I am writing here, this was A, this is B, even and odd function. When a function is even and when a function is called odd function, there is an easy way to check the even and odd functions. Just see here, if f of minus x equals to fx, you have to test, you have to substitute the x with the minus x and then find the result. If it remains fx only, then it is the even function always. So it is the even function. And f of minus x equals to minus of fx, then it is the odd function. As for example, if we take, I am writing the example here, if we take fx equals to x square. Now f of minus x, it is minus x square, that means x square only, that means it remains fx, so it is the even function. Taking, that is fx equals to x. So when fx equals to x, I am writing f of minus x equals to, then it will be minus x, that means minus of fx. So it is the odd function, and for here it is the even function. Very easy. Actually this type of question will be given to you and you have to solve, that is you have to check whether it is the even function or odd function. Okay. Students, now we will do some applications of the concepts what we have learned just few seconds ago. Here, find the sum and difference of identity function and modulus function. Find the sum and difference of identity function and modulus function. You know those. What is the identity function? What is the modulus function? We have discussed a lot with those concepts. Now, how to write? How to do those? Actually, from the operations on the functions, this type of question can come. So, let f R2R is a identity function, is identity where, so what is identity? Fx equals to x, that is the identity function I am writing. Fx equals to x for all x belongs to R. This is the identity function, and I am also taking g, another function from R to R, because the domain of the identity function and also the modulus function is from R, that is the real number set, R to R, such that gx equals to mod x. This is the modulus function. Okay. Now we have to find the sum and the difference of those two functions. So first of all, we have to check the domain of the resultant function. Here we know the domain of the identity function is real number set, and also the modulus function is the real number set. But what will be the domain of the sum, that is the f plus g, that function, and what will be obviously of the f minus g, the domain and range. So let us check what will be the domain and range. So first of all, I am checking here only. Domain of f is R, domain of g is also R. So domain of f intersection domain of g will be also the real number set. Actually, why we are taking the intersection here? The function f plus g or f minus g, that will be defined from the intersection. Then we can take the full f plus g. I am saying like that. Here the r is there, that's why we can say that is both are r. So why it will not be defined from r? But if it was the another sets, suppose one set is a, another set is b. So if those sets are there, then for f plus b or f minus b, if we define the function from this common region, then obviously we will be able to do the operations. That's why we have to find this one. Domain of here I am writing domain of f plus g will be R also, and domain of f minus g will be also R. Okay. Number 1, here f plus gx, we know from the definition it will be fx plus gx. So fx means it is x and gx means it is mod x. Now mod x means what? Here if we write like that, x plus, here I am writing like that, x if x is greater than equals to 0 and minus x if x is less than 0. This is the definition of the modulus function. So that means now we will just apply the addition here. So it is coming x plus x if x is greater than equals to 0 and x minus x if x is less than 0. That means 2x if x is greater than equals to 0 and 0 if x is less than 0. So this is only the addition. Look, very easy, not at all a hard concept, very easy concept, just you have to arrange like that. Okay, so let us do the subtraction here with the similar logic. So f minus gx equals to fx minus gx, you know this one. So that means here fx is x minus mod x. So if we apply this concept here, then what will be x minus mod x? So x minus x is greater than equals to 0 minus x is less than 0. So that means x minus x when is x is greater than equals to 0, x plus x when is x less than 0, and so 0 when x is greater than equals to 0 and 2x when x is less than 0. Simple thing. Here it is coming just opposite to the previous one, but those are quite easy. In this way you have to find the result. Let us take another one. So students, our next example is find the quotient of the identity function and the reciprocal function. You all know about the identity function and the reciprocal function. That is, identity function is so it will be defined from R to R, f such that R to R such that fx equals to x. This is the identity function. Reciprocal function g such that R minus singleton 0 to R such that gx equals to 1 by x. Why we have taken the singleton 0 outside? Because 1 by 0 is undefined. So for reciprocal function at the domain, the 0 element will not be there. Now we have found this. This is the domain of fx, this is the domain of gx. Now what will be the domain of f intersection g? So here domain of f intersection g. Those are the domains of the identity function and reciprocal function respectively. Now what will be the domain of the quotient? Quotient means here, that is I am writing in directly domain of f by g. This is the quotient. So that means here the domain of f intersection domain of g. This will be the domains. But here one trick is there. That is, here we cannot take properly the intersection because here the 0 is being omitted from here. So while 0 is being omitted, here we have to write like that. That is x such that gx equals to 0. We cannot take this point. It is inside the intersection of those two functions, but we have to take off that one. Otherwise, if gx equals to 0, this will not be defined. Fx by this, that is f by g of x equals to fx by gx, you know. Now whenever gx equals to 0, then it will be undefined. So we have to take outside that one. Now gx equals to 0. Here if we write like that, I am writing here equals to domain of f intersection domain of g. Now what is the value of this one? That is whenever which x we are getting such that gx is coming 0. no any x's are there because gx equals to 1 by x, and no any x will get such that 1 by 0 will be there. So that's why this will be 5. Gx cannot be 0. 1 by x cannot be 0. If we take 1 by x is 0, that means what we are getting? 0 equals to 1. This is meaningless. Here, if we put gx equals to 0 like that only, so we are getting 0 equals to 1. It is meaningless. That's why we cannot take that one. So no any x is there such that gx is coming 0. So this will be 5, the void set. So originally what it is coming now. So that means the domain of f intersection the domain of g, it will be real number set intersection the real number set minus singleton 0. So originally it is coming the real number set minus singleton 0. This is the domain of f by gx. Now f by gx or f by g such that the real number set minus 0 to real number set is equals to by gx equals to fx by gx equals to x by 1 by x equals to x's square. So originally what it is, we are getting f by gx equals to x square, where x is belongs to this. This is the result only. So originally what you have to do, you have to check the functions, the domains. If something should be omitted, you have to take off that one, and after that you will get the result. Very easy. I am giving 2 homeworks for this concept. So students, those are your homework. Just jot down those, and also before that just write down whatever the concepts and examples we have discussed here. And also I am seeing here that it is all about 20 minutes now, so the video is going too long. That's why we are making just another part of this video, that is where we will discuss about the composition of the functions and the invertible functions. Those are 2 concepts, those are left. So students, stay tuned for that video and also do those homeworks. So thank you students for watching this one.